Hi guys, my name is Trevor Sullivan and welcome to another CBT Nugget skill in the Certified Kubernetes Administrator course. Now in this particular skill, what we're going to be focusing on is the use of something known as liveness probes, as well as startup or init probes, as well as readiness probes, which are three different types of probes that you as a Kubernetes administrator can use to ensure that your application is healthy. So imagine that you are a developer or a DevOps engineer, and you want to make sure that your cluster is in a healthy state, and you want to make sure that all of the pods that are supporting your application are in a healthy state as well. After all, you've got lots of different application end users over here who are depending on you to ensure that the applications running on your cluster are reliable. So perhaps you as an administrator are going to build a Kubernetes manifest file here, and that manifest file may contain a couple of different components. You might create a deployment controller that deploys a couple of pods, and each of those pods might have containers running a web application in there. And then separately, there might be a second container in each of those pods that is responsible for taking logs from the web application that's in the same pod, and then forwarding those logs to some kind of external logging system. You know, that could be a cloud service like Amazon CloudWatch, it could be Elasticsearch, doesn't really matter, but basically you've got a couple of containers running in each of these pods here. And in order to access the application that's running in those pods, you also add to your Kubernetes manifest here, you also create a service controller. Now, the service controller can automatically create a load balancer for you on your cloud provider, such as Amazon Web Services. It'll just automatically create a load balancer, and then you can set that up to receive traffic. I haven't shown the load balancer in this particular diagram, but you can kind of imagine that your application end users, in order to access this service, they're going to be accessing it through a load balancer, and then the service, which is a Kubernetes internal cluster resource, is going to be responsible for balancing traffic across multiple pods. Now in this particular diagram, I've just got two pods, but you might have a lot more than just two pod replicas. Maybe you have a deployment controller that's dynamically being scaled up and scaled down depending on traffic demand, and you might have 10 or 20 or 30 pods, right? But in this particular case, we just have two pods representing the website. However, imagine that one of the containers, the kind of primary application container in each of these pods, were to go offline. If you were to lose the two web server pods in your application, however, keeping your logging agent up and running, then your end users are ultimately going to experience breakage in your application, right? They're not going to be able to access that web application that was running in one of the containers within your website pods, right? So how do we ensure that if for some reason our applications that are running in these pods were to die, how do we make sure that Kubernetes keeps them up and running? Well, the liveness probes and the readiness probes and the init probes, or the startup probes in Kubernetes, help us to accomplish that. So what we can essentially do is at the pod level and the individual container level, we can configure what are known as liveness probes. And you can think of a liveness probe as something like a command that you can run inside of a container to ensure that your application is healthy. So if you have a pod that's running a web application, maybe one of the things that you want to do to ensure that that web server is healthy is to simply run a command line utility that makes an API call against your web application. So you can configure a liveness probe to be just a shell command that you invoke. You could use something like curl or wget or the popular HTTP IE or HTTP utility. I'm not sure really how some of you say that, but really any command line tool that you can use to invoke a web API or to just call out to a website and just try to download some HTML from a remote website, you could use those types of utilities to ensure that that web application that's running in that container is alive and healthy. And then separately on your logging agent, you could also configure another type of command to ensure that data is actually flowing through that logging container to ensure that it's actually healthy, right? You want it to be picking up logs from the web application and then feeding those logs into some kind of external system. So maybe you could use something like network traffic as a metric to ensure that data is actually flowing through there. or some other kind of command just to make sure that maybe the process itself is running, like the fluentd process, for example, if that's the logging agent you're using, or some other agent, just to ensure that the actual process is running. And if for some reason it's not running, then you can mark that container as unhealthy using these liveness probes. Now you can also do another type of monitoring aside from running a shell command. You can actually do a TCP-based test or an HTTP-based test as well. Now you do an HTTP-based test or even a TCP-based test by using a shell command. By using a shell command, you have a little bit more flexibility in terms of what you can do because you're not limited to just an HTTP test or just a TCP or UDP port test. However, if you are just doing HTTP-based tests or TCP or UDP port testing, then the Kubernetes APIs actually provide for that so that you don't have to necessarily call a command line utility separately. So those are kind of the three different options that you have to set up liveness probes, is kind of a shell command, an HTTP-based command, or a port test against a TCP, UDP, or SCTP port. So you've got a few different options there, but then there's also the startup type of probe as well. And the startup probe is really designed for any application that's going to take a long time to start up. So imagine that you've got, some legacy web application, and maybe every time that a new web application instance starts up in one of these containers, maybe it takes, 45 seconds or maybe 2 minutes or maybe 5 minutes in order to, load some data from a remote endpoint or perform some kind of computational step that takes some time in order to execute. So what you can do is set up something known as a startup probe, and essentially when a new pod is created by Kubernetes and it spins up a container with your application running inside of it, then the startup probe will prevent Kubernetes from marking that container as being healthy until the condition that you set in that startup probe is actually met. So that's a way that you can kind of launch a pod but hold off on sending any traffic to that pod until it's actually marked as healthy based on some condition that you are able to specify as an application developer or as an administrator. And then the other type of probe that's actually really useful as well is the readiness probe. And the readiness probe is a little bit different because what it does is it basically determines if a container within a pod is ready to receive traffic. So what's a little bit, it's kind of hard to understand what the difference is between liveness probes and readiness probes, but the best way that I could really describe it is that a liveness probe is basically just checking to ensure that your application is actually running. So it's making sure that, your web application is being responsive. The difference with a readiness probe is that you can actually temporarily mark a pod as not ready, and basically you can opt to not send traffic to a pod that's not in the ready state. And so by doing that, you could take a pod temporarily offline without necessarily having to kill it and then restart an entirely new pod. So if maybe you have some kind of scheduled task that needs to run and you just want to temporarily take a pod offline, but you don't necessarily want Kubernetes to see it as unhealthy to the point where Kubernetes is actually going to kill the pod and then start an entirely new one, you can use a readiness probe to basically just temporarily take that pod kind of offline, so to speak, and put it in a not ready state so that you can do some, back-end maintenance or take a snapshot backup and basically do that without the interference of ingress traffic into that pod. But it won't cause the pod to be deleted or rescheduled or anything like that. The liveness probe can be used to basically say, okay, well, this pod or this container is healthy, it's up and running, but the readiness probe separately is just saying, I just need to take this offline temporarily, but in a few minutes, I'll be back online, or maybe even a few seconds, depending on what kind of task it is that you need to do to temporarily take the pod offline. So those are really the three types of probes that we'll be talking about in the rest of this skill: the liveness probe, the startup probe, and then the readiness probe as well. So the syntax for these is pretty straightforward. In fact, if we just take a look at a quick example here, you can see that the liveness probe is actually configured at a per container level. So remember, pods can have more than one container. In the diagram that we had right over here, we kind of showed how maybe you have a website container running, a web application, and then a separate container, but part of the same pod, running a logging agent. And so you can actually configure separate liveness probes, separate startup probes, and separate readiness probes for your individual containers within your pod configuration. So we'll take a look at an example of how to configure these probes in your Kubernetes manifest so that you as an administrator can deploy applications that are self-healing, resilient, and really provide just a good overall end user experience for your business applications. I hope this has been informative for you, and I'd like to thank you for viewing.